Oh, maybe I can. I've been logged out. Okay. Just a second. It's a great start. Oh, jeez. Okay, I think. Oof. That was like 3 minutes setting up the monitor. Okay, that's fine. Shit happens. Shit happens. Why do I sound so weird? All right. It's been a couple of days. Can't remember what I. Let's just test. Source VM. Okay, I did fix that. Okay, both of them work. Yeah. Okay. I did read ahead a little bit, and I was wondering about the same. Because right now there is no scope. Everything's visible. The function. No. I mean, everything's global right now. All the variables. Blah 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 blah. Will this work too? Let's find out. Okay. What's the test? Return 1. Okay. Return 1 returner returns a function. Okay. One way to find out. Oh, I forgot to update the test. And there's an assertion failure. Should be int the value equals 1. Just realized something I need to check. Function literal. Okay. Trying to yes, because I think I don't support implicit return. I think. Yeah. Just to double check, hope return self.remove frame pop. Yep. Okay. Local bindings. Yep. This one it could be easy or a lot of work. Where's my symbol table? Because I think I took a few shortcuts with the symbol table. Oh, I don't even use it. Interesting. This could be a lot of work. Our current implementation of functions and function calls does not support local bindings. We do support bindings, but only global ones. Local bindings are different in a crucial detail. in that they are local to a function, meaning that they are only visible and accessible within the scope of a function. This detail is crucial because it ties the implementation of local bindings to the implementation of functions. And what was the crucial detail? I read it, but I can't. Yeah, only global ones. Local bindings are different. Okay. At the end of this section, we want to have piece of monkey code working. Global seed is 50. -1 is a function. Yep, this should work. Okay. I guess should we also check if these are accessible outside of the function? All right, okay. Yeah. I think that's what we're testing because both of them have the same name. Okay, makes sense. And we also have the local binding num showing up in both functions. Important about num is that it's not accessible outside these functions, and that both bindings of num in each function are unique and don't override each other. Right. In order to get this piece of code compiled and executed, we need to do a few different things. Okay. First of all, we need to define opcodes that tell the VM to create local binding to retrieve them. Yeah. Okay, I see. So right now, why do I use scopes? I don't think I ever did it. Implemented the symbol table. Okay, hang on. First of all, we need to define opcodes that tell VM to create local binding and to retrieve them. No, I didn't guess it. Define opcodes that tell the VM to create local binding. Oh, okay. Cause code. Excuse me. We use op constant. Okay. Retrieve them. Then we need to extend the compiler so it can output these new opcodes correctly. This one is easier because these are only visible within the function. So when we compile function literals, something happens. That means it needs to distinguish between local bindings and global bindings. And also between local bindings with the same name in different functions. Why does this matter? Because shouldn't it be local to this function? The last step is to implement these new instructions and local bindings in the VM. We already know how to store and access global bindings. That knowledge won't be wasted, since the main mechanism behind bindings won't change. But for local bindings, we need a new store. As always, take some small steps and start at the beginning. I do have to say, I like the way he's structured the book. You can just read the text, try and implement it yourself, and then just double check. Not double check, I mean, you could see it like a different way of implementing it, maybe. Not sure if it makes sense. Right. We already... Excuse me. We already have two opcodes for bindings in place. Opset and get. Right. Now we need equivalents for local bindings. That's actually a good point. How do we know when to get global within a function? Oh, if op get local fails, we get global. My guess. Opset, opget local. The important bit is that these opcodes are distinct from global ones. They should tell the VM that the binding is local and the currently executing function that it should have absolutely no effect on global bindings. The binding shouldn't be overwritten, shouldn't overwrite a global binding, and it itself shouldn't be overwritten by one. And since defining opcodes is a rather dull task, we'll treat ourselves to a little flourish. Instead of giving these new opcodes the 2-byte operand their global cousins have, we'll use 1 byte. I don't know how that's better. Which we haven't had before, because isn't that an index? Oh, okay, I get it. You just left shift it. No. Is it a left shift? I don't know. I have to think about that. Okay, but I get what he's trying to do. He's trying to do something different. And also it kind of makes sense. Because a function shouldn't have that many. Shouldn't. But I do right. Yeah, I think 256. Good enough. I'm not sure if I handle. Is it 8? Yeah. Might need to update more things. Yep, exactly. That's what I guessed. Yep, I think this is not too bad. Read. We can now produce new instructions with 1 byte operands, but we can't decode them. We need to update our read operands function. I haven't looked at these in a while. Don't even know what they do. Okay, the make doesn't work either. Compiling locals. Okay, I'll just add the code first. Okay, and change that to local. Do the same. Yeah. Okay, then excuse me. It's only 1 byte, so I think 2, 3, 4, 5, 6, 7, 8. Oh no, this will be can I just encast it? Set button less than machine maxent. Okay, smaller. Can be less than or equal to. Yeah, I think this one. Start and byte. I think that's yeah. Now I'm not sure how this works, even though I did it. There should be, so say byte, 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 byte. That's 64. Oh no, that's only 32. 16 and 16. I guess that's why the assertion's there. Now. Make. Global to local. 5. Okay. Take test source / code. Okay. There's 2 more places. Compiler. Oh no, it's fine, because read. I think I did it in place. Check offset global. Instructions, position, scopes. New instruction is operand. Yep. VM. Yeah, I think it's done in place, so I don't have methods for these. Do I need to assert that the instruction is less than? Probably. Oh, I think it's a good idea. Instructions of IP +1 index. Set index is less than or equal to the max int 16. and get. Hey Taras, how you doing? Think I made a mistake. I want to sleep, but I can't. I'm at work and I need to pick up my daughter in an hour. Oh, that sucks. Oh, constant. Instructions of IP plus 1. So the compiler should still, well, yeah, it will work because we just say test source. Yeah, there's no reason for it to fail. What am I doing? I think I can extend one of these. Not this one. Not that one. This one. At y equals 5. return +5. So I need to set and a get. It should now be 10. Interesting. Local. Zero. Or 1. I think it should be 1. Then there's a constant. So get the local, get the constant, and add. Sorry, add the instruction. Yep. I mean, that looks correct-ish. What happens if I run the test? Source compiler. Interesting. So the number of instructions are correct. I did expect it to fail. It should have failed in a different way. This doesn't look right at all. So that should be the first. So up constant. And then 11. What's 11? Oh, sorry. Minus. Yep. I think that's just not right at all. I mean, but at the same time, I understand why. Function. Ooh, let's roll. Oh yeah, to be fair, I think I'm jumping way ahead. Read operants. Yep, this one. So far, I don't need to change anything. Oh yes. What is this test for? Okay. Yeah, this one's fine. Code. Okay, I think one of these could set, and then the test source code. Okay, that one still works. Read operand. Why is this here? Okay, because he uses this helper to read the input. I don't need that. That's fine. Right. It just converts it into, that makes sense. I mean, that's what I did too. Compiling locals. Yeah, this is the function. Let num equals 55. Set global constant pop. Right. Get global. Okay. I think I can add that test first. equals 5. Then option turn x, just call it. Integer, no, 5. Let me write this one first. Up set global, up constant, don't need get. This is the part that I'm not sure of. Let me check one of my up constant, call pop. I need one more constant to save the function itself. This is 0. Because this is that's a constant, first one. And this also is a constant. One, and then you call and pop. Okay. And now in the function there is get global and then up return. Should be 0. Take test source compiler. Expected 11. Is it really? Oh no, the order is wrong. It's constant. Why constant first? Damn. Zero, set global. Constant 1 and pop. Set global. Constant, call and pop. And then get and return. Okay, the rest look the same. I mean, that one would pass because right now there is no set or get local instruction. written. Yeah, I think this one should fail. I'm not sure how to do this yet. Because when we compile function literal, yeah, this one will definitely fail. I forgot why constant came first. I guess because you gotta add the constant to the stack. Yep, and then you have index 0. Okay. I mean, all of this will fail. Extending the symbol table. Actually, I don't think my symbol table knows even one scope. I now need to extend it so that it can not only tell different scopes apart, but also in which scope a given symbol was defined. Sorry, got totally distracted there. Only knows about one scope, the global one. We need to extend it. Right, okay. Yeah, I think there's okay, I'll just try it here. So let's say we have function index equals 5. I think 1's enough. Return 5. X. Call this, and then above, let's say there's X. This bit is easy, and maybe one more. Yep. This one is global. You can always check. I think global is the 0th index. But these two, question is how to differentiate this. Compile time, runtime. I think during compile time, increment. Gotta check. Do I even use this? No. Add global variable. Yeah, I don't think I use the symbol table. Actually, could add it here. So you only get it from the current scope. And if it doesn't exist there, you check the global one. Okay, that's currently our symbol table only knows about one scope, the global one. We now need to extend it so it can only tell different scopes apart, but also in which scope a given symbol was defined. More specifically, we wanted to just tell the symbol table when we enter or leave a scope. In our compiler, when we enter or leave a scope in our compiler, and it should keep track for us in which scope we're in and attach that to every symbol we define in that scope. And then when we ask it to resolve the symbol, it should tell us which unique index a previously defined symbol a previously defined symbol has and in which scope it was defined. Okay, it should tell us the index and the scope. Once we make our single symbol table recursive, but before we do that, here's a list of requirements. Do I even have? No. I think I have to do all of it. I wonder why I skipped it. New enclosed symbol table. I think, yeah. So when we enter a function literal, we get a new symbol table. And you should use it till, not sure. No, thank you. But I still have one more question. If we attach the symbol table, what's that? Get switch dash say head. Did you type in the wrong? Okay. I mean, I don't know what to do with that information, Taras. Okay. I don't know. I've never tried to name a branch as head. Will be not liked but git. What does that mean? Oh, okay. I don't think git cares. Yeah, okay, I see. We'll start complaining about each time we use git. Okay. Yeah, I guess just don't name it head. You could name it so many other things. I think that's it's a simple solution. I think there's better way to do it. Why do you want to break things at the company? Well, maybe don't answer that. I think it's fine. We go one step further, create a third symbol table, second local, internal pen testing. Okay. already pushed my changes once somewhere I shouldn't be able to. Okay. I don't know, my commits added to. I bet they love you at your company. Okay. I mean, that's a strange. Like, I guess because you use your own implementation. Not implementation, sorry. Okay. I mean, you only need to test that if it's public, right? Or is it to keep you safe from sabotage from within? Go one step further, create a third simple table, second local that's enclosed in first, which in turn is enclosed in global. Okay, I kind of see where this is going. In global, we again define more unintentional things. You mean we just want to check nobody does it by accident? Both enclose simple tables. We also define. Right, so I'm guessing it's the same symbols. Okay. Fair enough. The expectation is that defining symbols in one local table does not interfere with the definitions in another one. Yeah. And that resolving global symbols in a nested local variable still involves resolves to the correct symbols. Finally, we also want to make sure that the index values of the symbol defined in second local again start at 0. Okay, yeah, without being tied to other scopes. Must also have an effect on the define method of the symbol table. First define. Yeah, I think I need to implement the symbol table. I'm feeling a bit lazy to do it this way. Might think of something else. Okay, I think this is a problem for tomorrow. I think I need to implement it first before I can extend it. Okay, Taurus, I'm feeling a bit lazy. Gonna call it a day there. Hope you get some sleep later and have a good day.